Okay, guys, so we're going to get into transformations now, which, if you took intermediate algebra, you did do this. And what this is this is graphing, but the graphing that happens, what happens is there's this thing called a shift that occurs, and a stretch, and maybe even a condense. And by changing certain things on these graphs, you ultimately make the parent graph look different. And when I say parent graph, I'm talking about, for instance, y equals x squared. We call this the parent graph because every other parabola or quadratic function, remember, this looks something like this. This is at the point 1, 1. We have one here at negative 1, 1. This is at the point 2, 4. Negative 2, 4. And so every graph that's a parabola kind of stems from this one. So for instance, let me point some things out. H and K are your shifts. H is the x-axis shift, and then K is the y-axis shift. One thing I want to point out to you, though, is notice that the negative h here in this formula, that means that whatever h is in the formula, it will be the opposite of it. So, for instance, let me give you an example. If I have y is equal to, let's leave a at 1, x minus 2 squared plus k. Oops, not plus k, plus 4. Let's say it's flat. Okay, I give you this equation and I ask you what's h and what's k. You're going to tell me, notice that this is negative 2, so that means h is equal to 2, while k is equal to 4. If I give you the following, y equals x plus 3 squared minus 2, in this case, h is actually negative 3, it's the opposite, and k is equal to negative 2. So you can almost think of h as like a liar, but it's not always the case that it lies to you. When you start doing conics, it stops lying, and so it's kind of a bad habit to say it's a liar all the time. But for the most part, if you think of it as a liar, that's how they taught me it in high school, and that's how I've remembered it. But it's mainly because of how the formula is more than anything. So when I say that's a shift, notice that this point here is at 0, 0. So what I'm going to do is I'm going to shift it h and k units to the left and up. So let's graph this one. We're doing y equals x minus 2 squared plus 4. That 0, 0 is going to move 2 units to the right because this is positive, and 4 units up. So this 0, 0, the blue one, is going to move 2 to the right, 1, 2, and up 1, 2, 3, 4. Okay, and then every other point as well is going to move that. So remember we had a point here at 1, 1 in blue and negative 1, 1. Those are also going to move 2 to the right, 1, 2, and then up 1. And then the same thing, we're going to go 1, 2, and then up 1 from where it was, or 4, I'm sorry. And then we get the same exact picture, but now it's shifted upwards. And we have the same exact graph. I know I missed, sorry. But it'll be the same shape and everything. It will just be moved in a space. Now, these are easier to graph for the most part, because if you have it in this form, you know where the vertex is, and you can, and for my class, I'm only concerned with if you understand the concept of the transformation, not so much the perfect graph, because even if you can, because if you have the right shape and you have it in the right position, you'll probably have the right idea anyway, or you'll have the right graph anyway. But not always are graphs given to us. Y equals, let's say we have this. They are not always given to us in this form. So notice this doesn't have an x minus h squared in this case, or even a k that we are aware of yet. And so we can actually do this. If we complete the square on this, Well, we don't even have to do that, actually. We can factor this. We have y is equal to, this is, let's factor. So this is 1, this is 2, this is 1 and 1, x plus 1 squared. Okay, so now this, what is a, what is k? Well, a is equal to 1, because you can't make, if it's 0, then if you multiply it to the other thing, that thing will go away, so it has to be 1. And k here is actually 0, because if you add 0 to something, it doesn't change anything. And h is actually negative 1. So if we graph that, we go to negative 1, 0, we put a point, and then we have the same parabola we've been graphing. Up 1 over 1, up 1 over 1, and let me pull up Desmos for you. Y is equal to, we said x. Y is equal to x squared, and then let's show you y is equal to parentheses x minus, oops, one. Oops. And so you can see that, oops, I'm sorry, it's plus 1. So as you can see, this red one just literally got moved over 1 unit to the left on every point. And you have the new graph that's the exact same thing. And so that's what a transformation is. It's something that either shifts or modifies the sizing, scaling of something. And so with that being said, you can get this in this form by factoring in this case. In some cases, you have to complete the square, which always works. If you complete the square, you can get it in this form. So that's one reason why completing the square is good to use. If you don't like graphing the actual thing, another way you can graph, you can make a t-table, x, y. The only thing that you need to know, though, is that you need to be able to find the vertex of this thing, because if you can't find the vertex, you're not going to get a good accurate picture of the graph, because the vertex shows you where the middle, either highest or lowest point is, and if you get all the points on the right side, you're only going to see something that increases. You won't even know that it actually bottoms out somewhere and then increases on the other side. So make sure that you keep that in mind. The next one is the square root function. The square root function has a parent function that looks like the following. 0, 0 is a point, 1, 1, 1, 1, and then I believe 4, 2. And so if I give you y is equal to, let's say in this case, 2 square root x minus 1 plus 1. Well, here h is equal to 1, and then k is equal to 1. So what that means is this point 1, 0, 0 is going to move up to 1, 1. So your new graph is going to start here. And then your a here is 2. So every point after is going to be stretched upward a little bit. So instead of it being like that same curve, it's going to curve a little bit higher. So it's going to be a little bit more stretched out, a lot more wider, I guess. Okay, so with that being said, let's see. What did I want to tell you? Oh, let's talk about domain and range. If we did the domain of the parabola, all real numbers, negative infinity to infinity. We know that because it's a quadratic. You can plug any number you want into x and you will get a number back. The range, that depends on the lowest point, the vertex. So if you want the range, you use the vertex, and it's either the highest or lowest point. If it's the lowest point, then it starts with the lowest point, and that will be included. Let's look at this value here. We said this one, we're looking at this graph. So this lowest point is at 0, so that's included, and it goes up to infinity. If we had an upside down one that went through 0, it would go from negative infinity. Oops, that's gross. Negative infinity to 0. And that would be your range on it. If we go to this one, the domain's a little bit more limited. Remember, this is a square root, so we have to find the limiting factor. In this case, this h is what determines the domain. Domain here is going to start at positive 1 and go off into infinity. And the range is going to start at 1 and go to infinity. 1, 1 was our point. This relies on k, this relies on h. If it was upside down, and this was the point 1, 1, same thing. We'd have 1 infinity, and then we'd have from, negative infinity to 1. And so it's important, you guys, that you go from bottom to top, left to right to figure out domain and range. Just practice these. You'll see these on Alex. They're realistically, guys, what I'm shooting for is I want you to know what the shifts do, how they affect the graph, and what the shape of the graph is. Those are the main key points that I want. Like, for instance, if you see a square root, you should know that it's a halfway sideways, a half of a parabola sideways. If you see as x squared, you should think, oh, this is a quadratic or a parabola. If you see an x to the third next to an x squared, you should think, oh, this is a cubic. It's not a quadratic. Why? Because the highest power is what determines the shape of the graph. So keep that in mind. The highest power determines the shape of the graph, and you should memorize these. It will make your life easier in the long run. Thank you guys for watching. More videos to come.